Hello and welcome to this video presentation on the basics of voltage drop. My name is Martin Lavachka and in this video I'm going to explain what the voltage drop is, what the impedance factors are, why determine the impedance and the solution to reduce the voltage drop in an electrical installation. So let's begin. What is the voltage drop? We can define voltage drop as the decrease in voltage in a circuit due to impedance. Some of you may be wondering exactly what impedance is, so the definition below is helpful. Impedance can be described as a limitation of current flow in an AC circuit due to the combined effect of resistance and reactance. Let's move on to the next slide to explain. When carrying load current, there is a voltage drop between the circuit source and the load terminals. In the image, we can see an electrical circuit breaker panel with an operating voltage of 120 volts, supplying power to the load, in this case a plug, and this circuit is connected by a 100-meter long cable. As electricity travels from one point to another, there is a voltage loss of 10 volts due to impedance. The cable is a good conductor of electricity, but the impedance is not negligible even if the cable has low impedance. There are three factors on which the impedance of the cable depends. The first factor is the nature of the conductor. It depends on whether the conductor is copper or aluminium, but most of the time we will find copper conductors in electrical installations. The second factor is cable cross section area, or CSA. The thinner the cable, the higher the impedance. The thicker the cable, the lower the impedance. And the third factor is cable length. The longer the cable, the higher the impedance. The shorter the cable, the lower the impedance. Let's move on to the next slide. There are three main reasons for determining voltage drop. The first reason is compliance with current particular rules and regulations. The second reason is to keep the voltage drop at the level that can be tolerated by the load. And the third reason is to maintain operational requirements at a satisfactory level. To comply with IEC standards, the total voltage drop value cannot exceed 5 to 8% depending on the type of supply. In low voltage installations fed from a private low voltage distribution system, the maximum voltage drop allowed by the IEC standard is 6% for lighting and 8% for other uses. In low voltage installations fed directly from a public low voltage distribution system, the maximum voltage drop allowed by the IEC standard is 3% for lighting and 5% for other uses. What level of voltage drop can a load tolerate to maintain proper operation? It depends on the voltage at the load terminals remaining close to its nominal value. Let's take a motor as an example. The inrush current of a motor during starting can be 5 to 7 times its full load value, or even higher, and can cause a very high voltage drop. However, this higher voltage drop is acceptable for a short period. In general, the voltage of properly operating motor should be within plus minus 5% of its nominal rating in steady state operation. It is important to mention that this voltage drop limit refers to normal steady state operating conditions only and does not apply during motor starting, simultaneous switching of several loads, etc. But what happens if the voltage drop value is higher? The value of 8%, although allowed, can cause problems with motor loads. For example, if a voltage drop of 8% occurs at full load, then a drop of 40% or more will occur during startup. In such conditions, stalling of the motor can occur, with consequent overheating and eventual disconnection, slow acceleration so that the heavy current load continues beyond the normal starting period, possibly having undesirable low voltage effects on other equipment. Or third, continuous loss of energy, which for continuous loads will be a significant waste of energy. For these reasons, it is recommended that the maximum value of 8% not be reached under stable operating condition in circuits sensitive to undervoltage problems. Typically, CSA is determined by the current driven by the load, but the length of the cable may modify your initial choice of CSA. In the case of a long cable, the high impedance value reduces the voltage at the load level. When you exceed the maximum allowable voltage drop, you will have to choose a higher CSA value. The CSA must be increased until a relevant voltage drop value is obtained. We come to the end of this presentation. Now you know the basic concepts of voltage drop in electrical installation. Thank you very much for watching until the end. Stay tuned for the next video where I'll talk about how to calculate a voltage drop.